Let me ask you something. What if I told you that a cozy wool sweater and a massive industrial oil rig are connected in a way you'd never guess? Today, we're diving into the hidden world of high-tech precision, and I promise you the connections we're about to uncover are pretty amazing.
So, what is it? What's the link between a simple sweater and a giant oil rig? I know, it seems impossible, right? But the answer all comes down to one thing: a shared secret of incredible precision. And to figure it out, let's start with the sweater. On the one hand, you've got this ancient, totally natural fiber, and on the other, this beast of modern industry. The secret that ties them together is a story of mind-blowing, microscopic precision, and it all kicks off with that humble little wool fiber.
You know, when you think of making something with wool, you probably picture an old-fashioned craft, right? But the reality is, the modern wool industry is all about hard science. The quality of that fancy sweater you're wearing, that's decided way, way before anyone even thinks about knitting it. It all comes down to unbelievably precise measurements.
For hundreds of years, judging wool quality was, well, basically a gut feeling. An expert would just feel it and, make a call. But today, oh, that's all out the window. Technology has totally taken over. Forget sight and touch. Now, every single characteristic of that wool gets a cold, hard number. And this shift from an art to a science, it's a huge deal for global trade. I mean, think about it. How do you make sure that a measurement taken in Australia means the exact same thing as one in Italy? Trust me, it's way more complicated than you'd think. Getting a truly dead-on, accurate measurement it's a nightmare. I mean, look at all the ways it can go wrong. You've got human error, the instruments can drift, even the weather can mess things up. That's exactly why having a global standard is absolutely critical. Without it, the whole system just collapses.
And believe me, getting to that standard was a long, hard slog. The main group, the International Wool Textile Organization, they started way back in 1928. But get this, it took more than 70 years of work before things like modern laser scanning were finally accepted for global trade. 70 years! That's decades of scientific progress just to make sure your sweater is top-notch.
So, what's the payoff for all this precision? Well, take a number like 25%. What's that? It's wool's limiting oxygen index. Sounds fancy, but here's what it means in simple terms. For wool to catch fire, it needs an atmosphere that's at least 25% oxygen. But the air we're breathing right now, it's only about 21% oxygen. So wool is naturally flame retardant. And that's not magic. That's just science. Okay, so we've got these super precise measurements of the raw fiber. Awesome. But now, how does that precision actually help us make the fabric? Well, that's where the robots and microscopes come in.
Check this out. This is a mechanical splicer. And the cool thing is, it doesn't tie knots to join two pieces of yarn. No way. Instead, it untwists the ends, overlaps the tiny fibers perfectly, and then retwists them into a completely seamless join. You literally can't tell where one piece ends and the other begins. And that kind of mechanical magic is only possible because we understand the wool fiber down to the microscopic level, like you're seeing right there. And get this, modern tech lets us skip weaving entirely. It's a process called needle punching. Here's how it works. First, you lay out this web of loose wool fibers. Then, this board with thousands of tiny barbed needles starts punching through it, again and again and again. Those little barbs on the needles grab onto the fibers and just tangle them all up, creating this dense, felted fabric. Not a single thread is woven. It's a totally different way to make a textile. All right, so the story of a modern sweater is really a story of microscopic measurement and incredible mechanical precision. Now hold on to that idea, because we're about to take that exact same principle of precision and scale it up. I mean, way, way up. We are going from the micro to the macro, from the world of a single fiber to the world of solid rock. And that, of course, brings us to our oil rig. So what's the challenge here? It's something called directional drilling. The goal is to steer a drill bit through miles of solid rock, but with the exact same kind of pinpoint accuracy we just saw with those tiny wool fibers. So how on earth do you do that? How is that even possible? Well, the key piece of tech is called a rotary steerable system, or RSS for short. The easiest way to think about it is like a smart, self-steering drill. It's what's known as a closed-loop system, which just means it's constantly checking its own position and correcting its course, all by itself, allowing it to follow these unbelievably complex paths deep underground. Okay, so how does it steer? The part that does the work is called the bias unit. Picture this.
The main drill shaft is spinning like crazy, right? Well, it passes through a sleeve that doesn't rotate, and this sleeve can actually push the spinning shaft just a tiny bit off center. That push creates a bias, and that's what steers the whole thing in a new direction. Now, the second key part is the pivot stabilizer, and this thing basically just acts like a fulcrum, like on a seesaw. That little push from the bias unit gets transferred through this stabilizer, and that's what angles the very tip of the drill bit. So a tiny, tiny little nudge inside the tool creates a super precise change in direction at the cutting end, which could be miles away. So how does the bias unit actually create that push? It's all about hydraulics. Inside, a valve directs super high-pressure fluid to one of 12 different sets of pistons. When one of those sets gets the fluid, they push out, deflecting that spinning shaft with just immense force, but also with incredible, incredible precision.
Okay, so it can push, but how does it know where to push? Well, this is where the brains of the drill come in. Packed inside this super rugged tool is a whole suite of amazing electronics. You got accelerometers, magnetometers, a special gyroscope that can handle insane heat, and of course, powerful computer processors. All these sensors work together to create a real-time 3D map of exactly where the drill is, deep, deep underground.
And just like that, we've come full circle. A wool sweater and an oil rig. You couldn't think of two things that seem more different, right? But as we've just seen, they're both only possible because of this hidden world of high-tech precision.
This all connects to a really powerful idea in science today. Is this idea that when you can control materials at the absolute smallest scales, we're talking atomic and molecular levels, you can achieve unbelievable things at the largest scales. It doesn't matter if it's the molecular structure of a tiny wool fiber or the exact angle of a massive drill bit miles underground. The basic principle is exactly the same. That sweater and that oil rig, they're both proof of the incredible power of precision.
So maybe the next time you pull on a wool sweater or you see a picture of some massive industrial project, you'll think about that incredible precision that's hidden just beneath the surface. And it kind of leaves you with a big question to chew on, doesn't it? What other invisible technologies are hiding all around us, right in plain sight?